Peace be upon you. Welcome to the Fixed Focus program. I am Ibrahim Hashemi, and this is another episode of Fixed Focus program. In this section, I want to explain about the solar tracker that is used in the fixed focus system. And the fixed focus system does not work without a solar tracker. So let's go for explanation and how to build a unique solar tracker system. Before we get into the fixed focus system tracker, it is necessary to mention very briefly about the limited number of solar trackers. To get acquainted with their work and have an overview of different types of solar trackers. In general, solar tracker are two examples. 1. Uniaxial tracker. 2. Biaxial trackers. Single-axis trackers move the system in only one direction. If you assume this is a solar panel page, the uniaxial tracker moves this page in only one direction, but the biaxial tracker moves the page in two directions, both in this direction and this direction. So it can cover 360 degrees of space. Solar trackers have been from the past, before electronics existed. For example, in this figure, a drip tracker is used to move the system. And proportional to the movement of the sun, drops of water would collect in the bottom container. And the upper container is emptied. And this causes the system to move. A uniaxial tracker. I will show you another old tracker that is more accurate. This tracker works with freon gas. This solar tracker has two freon gas tanks. When the sun shines on the first tank and heats it, the tank pressure increases and causes the piston to move. And the movement of the piston causes the system to move. And this tracker is also uniaxial. But there are different types of new solar tracker. Most of them work based on the comparison system. An example of this is this four-corner tracker, which is very simple and biaxial. There is a photocell in each corner of this tracker, which based on the comparison circuit, it can transmit the system in the direction of the photocell with more radiation. And stop when all photocells are equally irradiated. And finally places a page-like panel perpendicular to the sun. There are other systems as well. For example, this tracker uses a photodiode instead of a photocell. And because it has two photodiodes, it is a single-axis tracker. Any tracker that has at least 4 light sensors on its 4 sides is a biaxial tracker. We need a very accurate tracker in a fixed focus system, and many of these biaxial trackers do not work in the fixed focus system. We must use a tracking device that focuses the reflection of the solar dish exactly. Like a sniper that hits a target accurately. I use a pen tube to clarify the matter. And no light passes through the body of the pen tube. I put a small photocell at the end of the tube. Now if I put the tube in a position where sunlight passes through, and the transmitted light contacts to the photocell. In this case, the tube is parallel to the sun's rays. And the longer the pipe, the more accurate the work. And the photocell plane is more perpendicular to the sun's rays. But the problem is how to put the system in this state automatically. And it will make it difficult. I had made a sample several years ago. Unfortunately, I only have one photo of it. This is an example of a 360-degree solar tracker. As you can see, it is in the shape of a sphere. All the points you see include a photocell. The impact of light on each photocell directs the tracker in the direction of movement towards the main photocell. This is a biaxial tracker that has its own problems and is not suitable for fixed focus system. Well, let's introduce the tracker used in the fixed focus system. The solar tracker I used in the fixed focus system is an invention. This tracker is extremely accurate and inexpensive, and many people can make it with a little care and interest. This tracker is a 180-degree space tracker. That is, if we consider the whole space 360 degrees. The visibility of this solar tracker is approximately 180 degrees of space. That is, half of the space in front of the tracker. Suppose you are behind the sun, and suppose you have no shadow, so you can't guess the exact location of the sun. But if the sun is in your field of vision, and even if it is parallel to your field of vision, you can understand the location of the sun. Suppose this is a sunlight. If you place it on the left or right, you can feel it. The tracking I want to talk about it can determine the location of the sun with the same accuracy. Each of our eyes has a lens, and we cannot see without a lens. And our tracker also uses the lens. In the figure you see the types of convergent and divergent lenses. Diverging lenses are not effective in making trackers, so we only use converging lenses. I have used the convex lens before to make the tracker, but the tracker's field of view is very short. I have used a plano-convex lens in the system of this detector, and the result has been acceptable. In this figure, you can see a plano-convex lens in different lighting modes. The semicircle around the lens is the focal circle of the lens. As you can see, the light in the horizontal position can also be in the focal circle. I prepared a large plano-convex lens. Light will be focused on the other side of the lens from any angle that touched the flat side of it. From this side and from this side and every other side. Now with this flashlight I radiate light in different directions to the lens. Light in the 180-degree horizon can also appear on the other side of the lens. And this is a special advantage of this lens. An important part of this invention is that this lens has the ability to see 180 degrees. Well, let's go to the next step to see how we can prepare the lens. I have 3 plano-convex lenses of different sizes here. A large lens and a small lens. This is a medium lens. This is a small lens. This large lens does not suit here for us, so I put it aside. This small lens is related to a small LED projectors. Because our photocells are not very small, this lens does not perform well for us. But the average lens, the dimensions of which I will leave at the end of the video. A plastic lens, it is related to LED projectors, and the price is very low, and it does our job. And it does not need to be glass, because we do not want to do the work of a telescope. But one important point is that the focal point of this lens is not a point. So we have to do something whose focal focus becomes too small. That means we have to reduce the viewing width of the lens. To do this, we use a paper label sticker. And with a circular template, draw a circle with a diameter of 1 centimeter on the paper label sticker. The circle can be drawn smaller and does not cause a problem. Now we separate the circle with scissors. In the flat part of the lens, specify its center. I have done this before. You can mark or connect two diameters perpendicular to each other in the flat part of the lens. Do the same on the label circle. Try to place the circle of label exactly in the center of the lens. Now with a matte black spray I paint the flat part of the lens. This is a very important point, be sure to use matte black. Well, we leave the lens aside until the paint dries well. I have done this before with another lens. And I removed the circular label. The important point is that no light should pass through the painted part before removing the label. You can do this in the sunlight. Any light passing through the painted parts cause disruption will be tracker. As you can see, this is a welding goggle, and its smoky glass is needed by our tracker. With this smoked glass, the amount of light reaching the tracker is controlled. And it must be made of glass. Now, as you can see, the lens can be placed on top of a piece of PVC tube. And place the tube itself inside the larger tube. Smoked glass is placed on the flat part of the lens. And there should be no contamination between the two. This is where the optics part of the circuit ends. Well, now we have to calculate the focal length of the lens accurately. And because we do not know the refractive index of the lens. Therefore, in theory, the calculation will not be accurate. So we do this with a vernier. We stick a paper sticker on one of the outer jaws of the vernier. And we place the flat surface of the lens in the other jaw of the vernier. This must be done in the sunlight. And if we do this in front of other lights, the measurement will be wrong. The flat surface of the lens should be parallel to the surface of the paper label. Now suppose we are in the sun and the focus of the lens is on the label. By moving the movable jaw of the vernier, we keep the focus of light in the smallest position. In this situation, the focused light is the smallest. And the value shown is the same as the value of the lens focus. The focus of this lens that I obtained with this method is 62 millimeters. And this focal number is very important in the accuracy of the tracker. Now I will put the lens on a piece of PVC pipe. And we know that in this case, if light shines from any angle to the smooth surface of the lens, we will have light on the other side. If the light shines horizontally, the light passing through the lens will be on the wall of the tube. But if the light shines perpendicular to the surface of the lens, the focal point is located in the center of the tube, in which case the tube is parallel to the sun's rays. There are several ways to make the system perpendicular to the sunlight. For example, we can cover the inner body with photocell. That this method is not interesting. I have tried different methods to build a tracker. I will show you some of them here. For example, this tracker uses a pyramid system. The work of guiding the system is done by photocells on the pyramid plates. This is also another tracker, which works with the cone plate system. And building a conical system is a difficult task. This tracker is also made with a small lens. That's why its length is short. This is another tracker I have. This tracker works with a step system. This is another large tracker I have. This tracker works with 2 photocell cones. You have seen a number of different trackers here. I will first briefly describe the pyramid tracker. And then I go to the main tracker, which is already working very well on the system. The tracker on the system is a step tracker. And it will be easy and cheap to build. The 2-axis tracker must detect the movement of the fixed focus system in 4 directions. So the pyramid tracker should have 4 triangular planes. As you can see, this pyramid tracker has 4 separate photocell plates. In this figure, it is clear that the 4 triangular plates form a pyramid. The accuracy of the construction of this pyramid depends on your accuracy. In this figure you can see the components of a pyramid tracker. The part shown with number 5 is a single photocell at the end of the pyramid. And when the focus light hits it, that is, it is a parallel tracker of the sun's ray. Suppose this is a tracker that is to be installed on a fixed focus system. The tracker should be perpendicular to the dish plate. When the lens light hits the bottom photocell screen from above. In this case, the solar dish must move downwards, as long as the light hits the single photocell. And when light hits the top triangular plane, that is, the dish must move upwards. And if the light hits the right, the dish should move to the right. And in the left case, the dish should move horizontally to the left. And if the lens light hits both screens, the dish must move in both directions. In this figure, you can see how to build a pyramid from beginning to end. The photocells of each page must be connected in parallel. In this figure we have 4 large triangular plates and a small square plate for a single photocell. In the pyramid system, when light hits a single photocell, the system is locked and no longer moves until the sun shines and light does not hit a single photocell. The pyramidal system has acceptable accuracy. If building a tracker pyramid system is easy for you, you can trust it. I myself did not use this pyramid scheme on a fixed focus system. And I used a step system that is more accurate than this system. Now if you want to run a pyramid system with this lens and this PVC pipe,
اگر خواستید با این روش کار کنید در شکلی که مشاهده می‌کنید نحوه محاسبه‌شو بهتون میگم. داخل
First we measure the inside diameter of the pipe.
اندازه‌گیری داخل سیستم.
The inner diameter of this pipe is 36 millimeters. In this figure, the value of the base of the triangle is approximately 25.45 millimeters. And the height of the triangle, taking into account the outer edge of the lens, is 60 millimeters. This is a pyramidal system. And you can do this conically. Of course, building a conical system is a bit difficult. And you have to use a conical shape like a funnel. And this pyramid scheme is not a bad system and it is reliable. Well, let's move on to the new stepping system.
چگونه تهیه میشه.
The pyramid method uses a large number of photocells,
فوتوسل بسیار زیاده، همچنان که مشاهده می‌کنید خیلی فوتوسل
and it takes more effort to make.
بتونیم این سیستم رو پیاده کنیم. ولی در روشی که
But in the way I want to explain now, the number of photocells is much smaller
برای هم حتی دقیق‌تره.
and much more accurate.
یک
I made a printed circuit board according to the figure. In this figure, the diameter of the center circle of the circuit is approximately 1 centimeter, and the diameter of the printed circuit board is equal to the diameter of the PVC pipe. In this figure, photocells are divided into 4 groups, up and down groups and left and right.
روی لوله
This circuit accommodates 28 photocells when the lens is placed on the tube. If light hits the lens from the horizon, an image of light appears on the wall of the tube.
قرار میگیره و میتونیم یه سری فوتوسل رو در
Now we can place a series of photocells near the lens.
سیستم
This circular circuit does this for us. From any horizontal direction where light is emitted, a number of photocells related to the same angle are activated. On the other hand, another circular circuit is located at the end of the focal length.
یک تکه
To form such a structure, I use a piece of 1 cm PVC pipe, and I will put it behind the lens.
قبلا این
Then I put the photocell plate that I prepared before under the tube.
فوتوسل کار کردم در اینجا قرار میگیره.
After this I will put a 5 centimeters tube behind the circuit.
قطرهایی که در شکل مشاهده میکنید دقیقاً
In this figure, you can see the order of the components. The focal length is exactly 62 millimeters. At the end of the 5 centimeters tube, I place a circular photocell plate. The main job of this tracker is done by this photocell page,
مهمتر
and should be at the end of the pipe.
باید فوتوسل های
It is very important that the photocells in the same group are in the same direction in the upper and lower orbits.
دقیقاً در یک راستا قرار بگیره.
For example, the up group should be in the same direction in both circuits,
به این صورت چسب بزنید
and glue them with a suitable, strong and matte glue, of course, after soldering the communication wires.
چسب‌هایی استفاده کنید که دقیقاً ساریک باشه.
When the glue dries well, place the flat surface of the lens on the smoked glass and glue around it. The type of adhesive must be opaque, waterproof and not elastic. Cut the larger pipe according to the required amount and place it on the system. And then we glue it around.
قبلی که ساخته
An example that has already been made in the same way, I will show you.
همین سیستم هست و
2 screws and nuts are installed to place it on the dish.
قرار گرفتن در روی دیش خورشیدی.
An important point is that you must cut the pipes vertically,
این که ما بتونیم این سطح رو بسیار
and this is of particular importance.
یک روش
A simple way to do this is to use an A4 paper, for example.
کاغذ
First mark the place of measurement on the pipe. Then wrap the paper around the tube.
اندازه‌ای که می‌زنید روی مشخص کنید اندازه
Do this so that the edges of the paper are exactly on top of each other.
ها روی هم قرار میگیره با ماژیک دقیقاً این
And then draw a line on the pipe with a marker.
این دقیقاً نشون میده که این دقیقاً عمود هر صفحه است
And then we can cut from the pipeline.
و منظم و فرمود خواهد روی صفحه. خب ببینید که من
The wires to be connected to the photocell circuits must be very soft.
لوایی استفاده میکنید
Examples of wires that have this property are flat wires.
و اشکالی در کار نیست.
In the figure you see, it shows the end photocell circuit. In this circuit, 26 photocells have been used, and the up, down, left and right parts are marked. Let's go to connect the wires to the photocell circuit at the beginning and end of the detector. Well, now Now the wires are soldered. The output of each photocell page must be 5 strands of wire. One is common and the other is up, down, left, right. All wires of the same name on the 2 plates must be connected. Finally, the tracker output will have 5 wires. The important thing is before you put the parts together, all photocells must be tested. Because the photocell may not work due to solder heat. To do this, we first mark the soldered wires with a marker. The common wire with 1 line and up with 2 lines and down with 3 lines as well as the other 2. We do this for both photocell pages. Well, to test, first connect the common wire to an ohmmeter probe and the other probe, for example, to the up group. We prepare a piece of cardboard that light does not pass through it, then we make a small hole in the middle. We place the whole of this cardboard on each of these photocells. Set the ohmmeter to a factor of 100. If the photocell is healthy, the ohmmeter pointer should be the right size and move like the rest. And if the ohmmeter pointer moves a little, it means that the photocell has a problem and needs to be replaced. It should be noted that we used the smallest photocells available in the market. And it is better to test the photocells before installing them. And select photocells that are in an ohmic range. For accuracy in the cartoon, you can see the exact size of the photocell used in this figure. Another thing we need to do is put a mark in the top-up area and at the edge of the fiber circuit. We do the same for the bottom photocell page. Well, the top photocell plate is located behind the 1 centimeter tube. When we want to put a 5 centimeters pipe behind it, the wires are annoying. So we have to drill a small piece of the edge of the 5 centimeters pipe. Of course, be careful not to place the wires in front of the center hole of the photocell circuit. Well, I drew a straight line on the 5 centimeters pipe. Now when connecting the pieces together, the top point of both photocell plates should be along the pipeline. Accuracy in this work is extremely important. Another very important point is that we first attach the photocell plate with a central hole to the tube. Make sure the up sign is along the pipeline. And then with a paper towel from the outside on the center circle of the page. And now we paint the inside of the tube with matte black spray paint. In fact, there should be no light reflection in the tube. It means a dark room without reflection. And after the paint dries, we look inside the tube so that there is no reflection. If you pay attention, the photocell screen is also reflective. Opaque spray can be used to blur the surface of photocells. Apply the matte spray on the photocell plate and then let it dry. This spray allows light to pass through but blurs the surface. After this, we paste the last photocell page. And remember to matte spray on the front page photocells as well.
اینو هم سر جای زدم، آب با آب دقیقا زدم و چسب زدم. روی اینم باید حتما اسپری مارت بزنیم. بعد از اینم روی اینم اسپری مارت بزنیم.
Then attach the lens with a 1 centimeter tube.
اینو قرار میدم. الان من اینو به این چسبوندم، اینو به این قرار میدیم و این به این صورت قرار میگیره.
After the adhesives are dry, we cut a piece of pipe with a slightly larger diameter and a suitable size. And we put the build tracker in it.
قرار میگیره.
Of course, first we glue the smoked glass to the lens.
ساعتی اینو در روی اینجا بدیم. البته
Foam tape, glue, or Teflon can be used to fill the gap between the large and small pipes, and the space between the two pipes is removed. The size of the large pipe depends on your working conditions.
اگر خواستید مثلا میتونید
For example, in the sample you see, there are 2 screws and nuts to connect to the dish.
و مزاحمت
And these 2 bolts do not interfere with the internal tracker tube.
سعی کنید که
Do not forget to use matte and opaque glue. No light other than the lens light should enter the darkroom.
نباید وارد بشه. هیچ انعکاسی در اتاقش نباید وجود داشته. اگر انعکاس وجود داشته باشه باعث خطای کار ردیاب میشه. برای سرعت کار هم
For speed and accuracy in the cartoon, you can first use 1, 2, 3 adhesives,
چسب‌های قطری کیسه چسب‌کاری بکنید
and then apply the original glue on it.
انجام میدید. کاریدورش رو انجام میدید. خب پس نکته مهم این بود. و
I apologize to you dear ones that the time of the film has increased again, and I could not explain the tracker control circuit in this section. Of course, the tracker is the most important part, and the control circuit can be a simple comparator circuit. Any part of the video that was not understood, leave me a comment so I can respond as soon as possible. My whole effort is to be able to explain all the parts of a fixed focus solar system. I hope the programs have been useful for you so far. So until the next program, goodbye.